So in this segment, we're going to be looking again with the base 10 blocks, making rectangles or the array or the area model. And we're going to be looking at some of the typical multiplication strategies and just to show how we can connect those to a visual or to a concrete. So let's start off looking at this question. And I'm just going to take a second just to look at all the different ways that we might say this question. This is probably the most common, 6 times 5. Then we could have 6 groups of, or 6 sets of 5. Some people might say I have groups of 6. My multiplicand is 6, and I'm doing that 5 times, so groups of 6, 5 times. Some people might say 6 by 5 if you're using it in the array model or the area model. A room is 6 by 5, so you might see that. So there's many different ways of saying this math statement. And what I find with students is even what they say and what they mean are not the same things. I showed a student 6 times 5. I asked them, what does it mean? And they said 6 groups of 5. I said, could you write that down as an addition question for me? They said, okay. And they wrote down this. So they're saying 6 groups of 5, but they wrote down 5 groups of 6. So even when they say one thing, what they're really meaning might be something else. So it's important for us to take the time to take a look at these models, either in a concrete way or in a virtual manipulative way, just so that we can make sure what they're saying and what their meaning are in alignment with one another. So I'm going to say 6 groups of 5 or 6 sets of 5. So I'm going to bring up one group of 5, 2 groups of 5, 3 groups of 5, 4 groups of 5, 5 groups of 5, 6 groups of 5. So a student may not know what 6 groups of 5 is, but they could do some skip counting. So they've got 1 group of 5, 2 groups of 5 makes 10, 3 groups of 5 is 15, 4 groups of 5 is 20, 5 groups of 5 is 25, and 6 groups of 5 is 30. So they can say 6 times 5 equals 30. And I think it's important for us to show a written out mathematical statement for what they're doing. They may not recognize, and you may not need it right away, but when they see it being done constantly, kind of subliminally, they will be able to pick up on that later when it's required of them. What about the student who says, well, I don't read that as 6 groups of 5. I read that as groups of 6 5 times. Does my diagram work the same way? We want to show them that it does. So I'm going to move things around and so it's a little bit more visual to get 5 groups of 6 or groups of 6 5 times. So here, this first column is 1 group of 6, 2 groups of 6, 3 groups of 6, 4 groups of 6, 5 groups of 6. So I haven't really changed at all. I still have the 30 blocks. I've just put them more into columns instead of counting by rows. So the student can still see that this 6 by 5, 6 times 5, could be written as, over here, 6 groups of 5, but here we could talk about 5 groups of 6. And we're going to write down over here what that might look like. And there it is. Both looking the same question, 6 times 5, but this person is interpreting 6 groups of 5, and this person's interpreting as groups of 6 5 times. But now we might have the student that says, well, I don't know what 6 times 5 is, but I know what my 3 times 5s are. And they're going to use the doubling strategy for that. So let's show how that would look. They're going to take the 6 times 5. They're going to break it down into the things they know. They know that 6 is made up of 3 plus 3. There's my double. And so we're going to do that by 5. And we're going to distribute that 5 across. We're going to use the associative property and show them when they say I'm going to do the doubling technique, this is what we could write for that. We know that 3 plus 3 is 6, and those two 3's together multiplied by 5, so this 3 multiplied by the 5, there it is there, and that's a subtotal of 15. I know this 3 times 5 is 15, and the two 15's together doubled gives me 30 because I know my doubles. And visually, we have our 1, 2, 3, 4, 5, 6 rows of 5, and we're going to break it down into 3 groups of 5 and another 3 groups of 5. So this is a subtotal of 15, this is a subtotal of 15, and the two 15s together give us our 30. So there's our visual way of partitioning our question. I can also model that partitioning of the 3 by 5 this way, so it doesn't take quite so much time as to move all the manipulatives, because we want to move from the concrete to this symbolic, but we want to be able to make it flow. So this is a nice intermediate step. We take our 6, we've divided into 3 plus 3. We're still multiplying by the 5 on the top. I should probably have a 5 there on the top. So just 1 second, and I'll move that up there. So just make sure we're modeling the same thing. So it's 6 by 5 and 3 plus 3 by 5. And then we've got the two subtotals here, which is 15 and 15, and that gives us a total of 30. And another student might divide it up this way. Instead of 2 groups of 3, they might want to put it into 3 groups of 2. They know that 2 times 5 is 10. 2 times 5 is 10, and 2 times 5 is 10. So those all together add up to 30. We can use this model here, this partitioning model, so we don't have to draw the little squares. We still have 6 down the side, 5 across the top. The area of this one is a 2 by 5. It's 2 high by 5 across, 2 high by 5 across, 2 by 5 across, and we get our 10s. And then mathematically speaking, if we were to rate it out, this might be something we might want to write down for them to show them what it was that they were doing mathematically, to show your work. So we 6 times 5, broken it down into 2 groups of 5, plus another 2 groups of 5, plus another 2 groups of 5. Subtotals is 10 plus 10 plus 10, giving a total of 30. So we've looking at it in the concrete way, we've looked at it in a partition manner, we've looked at doubles, we've looked at repeated addition, and we've looked at the symbolic nature. I think it's important that when we may not be stressing the symbolic early on, but as long as they see it being done, they can make the connection between the concrete to an intermediate step to the symbolic step.